Okay, so we are going to, let me get us right up here. Thank you very much. So what we're going to do today is we're going to talk about zeros of polynomials. Now we've been finding them. You know, it's something we've been doing. We've been doing it through factoring and through using synthetic division to help us kind of break things down so that we can get quadratics, which we know how to work with through factoring, and then we kind of talked about, all right, what are these, why are we doing this, and that came to the idea of solutions, right, and solving these things. And so now we're going to draw the connections again, because this isn't the first time we've done it, but we're going to draw the connections again between what exactly a solution of an algebraic polynomial is related to its graph and what it actually means, right? And because the algebra, you know, serves as a tool to help us work better with the graph, not the other way around, right? It's all about the graph and kind of understanding these things, because if you think about what the purpose of graphs are, they're meant to help us visually understand a concept, right? That's the whole idea of a graph, right? Like sound engineers use sine waves all the time, and they look at them to kind of see like how they move and how they hit things, and that all stems from graphs, right? And once they understand that, then when they have algebraic representations of it, then they can work with things and manipulate things and do all that in a much more efficient way than with a graph. All right, so what we're going to do, sorry that was a lot, but just kind of giving you the why here, is we're gonna start basically by reviewing how to find zeros algebraically, just with a couple quick problems, and then we're gonna play around a little bit in another video with Desmos and what finding the zeros graphically looks like, and then and then it says here connection questions and summary. So we'll do that. So this will be about probably 3-4 videos, like normal. So let's get started, right? So what we're going to do now is review zeros of function, right? So a zero of a function is the input value that has an output of 0, right? So that's kind of what we've been doing. We use the zero product property to say, well, if this whole thing, if my output, which is your f of x, equals 0, right? If we have this, right, equals to 0, and this whole works, then what that means is that each of these has the opportunity to be 0 in order to multiply by everything and kind of zero it out. So there's 4 different options of what it can be, right? And so when we looked at what those are, basically you just kind of take every separate thing, right, and you set it equal to 0. So that's every factor, right? I shouldn't call it a thing, every factor. So you've got 1, 2, 3, 4 different factors. And I know in classes I was kind of doing it like this with like Roman numerals, right? Just to kind of show you how that looks. So like for case 1, right, you have x equals 0. That's one possibility. It's really nothing to do with that, right? That's sort of done. And so case 2, we've got x plus 1 is equal to 0, and it's a one-step equation, all right? And so in order, what we do is we want to get x by itself. And if you think about what that sounds like, it's when you say a solution, you would say x equals or x is, right? What is x? Well, x is. In order for that to happen, you have to have something that says x, and then our is our equal sign, right? That's what the equal signs mean, is, right? That's what it is. So when we're solving these things, that's kind of how that works. So we got to get it by itself. So let's subtract 1 from both sides, and you get x is equal to -1. So we've got one solution, 2 solutions. Let's do solution 3 here. So we've got x minus 3 is equal to 0, right? So we're going to add 3 to both sides, right? Sorry, we don't need that yet, right? I don't know what I'm doing here. Tired, apparently. So we got, let's try that again. All right, x minus 3 is equal to 0. We're going to add 3 to both sides. And now we're going to put our equal sign, and we'll get 3 and x. And then our fourth case is 2x minus 1. This is a two-stepper. You can always tell it's a two-stepper because you have a number on the coefficient, right? So that means the and and something's adding or subtracting to it. So we got some work to do, but not too much. Let's add 1 to both sides, right? And then you get 1, and you get 2x right here. And we're going to divide both sides by 2, and you get x is equal to 1/2. And so my my solutions to this, right, are this set right here. I've got -1, got 0, and then I've got 1/2, and I've got 3. And I just basically put these numerically in order from left to right so that we can kind of see these. All right, and now this one is more of a recent one. This is from my last lesson, right? And so what we want to do with this one is you realize that, hopefully you realize that, hey, I can pull some factors out of this thing, right? I hope you see that. So let's do that. Let's pull out 2x, because I can pull 2 out of this whole thing, and I can pull an x out. And I get x squared plus 2x minus 8. All right, and now we've got a quadratic that we know how to work with, and we've got this 2x, and we're going to set this equal to 0, because that's if the output is 0, the g of x in this case is our output, right? And then so if the output's equal to 0, you just make g of x 0. I'm just moving it to the other side, so it looks like something I'm a little more familiar with. So our first case is going to be this 2x equals 0, and we'll do that in a second. But let's factor this first, because we want everything down to x. X squareds are nice and everything, but that's not what we want to work with. So let's do let's first show you this using the AC method. Okay, so we're going to go a is your coefficient in front of x, c is this right here, -8. So we have 1 times -8. Is -8, and then 2 factors of -8 that add to 2, all right, would be 4 and -2, right? Because 4 times -2 gives me -8, and then when I add 4 and -2, I get that. So those are my 2 factors. So now what we're going to do is we are going to take this and use these and rewrite. We're just going to work with this, right? We're just working with this. So we're going to say x squared plus 2x minus 8 is equal to 0. So now let's rewrite it. X squared plus 4x minus 2x minus 8 equals 0. So what I did is I decomposed this to these 2 factors of it that add up to this. So it's an equivalent expression. And then we will factor by grouping. Let's pull an x out, and you get x plus 4. I'm going to assume I'm going to be able to get an x plus 4 over here, so I'm going to move this over here. And then I figure out what's my multiplier to go out here in order to get -2x and -8, and that is -2. And then let's regroup these things, all right? So we can factor that whole x plus 4 out of both. And then we got x minus 2 right here, which is like my leftovers that go into the next one. And now I've got this broken down the way I want it. It kind of looks like this up here, which is the goal. And then I've also got this piece right here. So we've got our case 1, right? So this is case 1, and then this is case 2 and case 3, right? So those are the ones we're going to do. So we got 2x is equal to 0. Well, if you divide both sides by 2, which really shouldn't have to if you kind of see what's going on there, you get x equals 0, right? We're good with that. 2, we got x plus 4 is equal to 0. Subtract 4 because it's the opposite operation. And you get -4 is equal to x. And then for my third case, right, looks like a smushed birthday cake or something there. You get x minus 2 is equal to 0. Let's add 2 to both sides. You get x is equal to 2. And so now my solutions, right, are this set -4, 0, and 2. And these are the 3 solutions. And I know that, you know, unless you have a double root, like if you have a perfect square trinomial or something, generally speaking, you're going to have the same number of solutions as your highest degree. All right, that's kind of, they call that the degree of a polynomial, and this is a polynomial of degree 3. And so I'm going to have 3 solutions. This one would be degree 4, because if you multiplied all your x's together, you would get something to the fourth power, right? And so we have 4 solutions, right? And that would be the maximum number of solutions you could have. You'd never have more than that. You could have fewer because you, like we said, you might have a double root, like a case where something rests on the axis. So this is just sort of a review of like how to do these, right? And then in the next video, we're going to play around with Desmos and see what happens. All right.